This video lecture supplements a workbook for Beck's Introduction to SQL Programming, the Pelican Companion. The corresponding textbook is Beck's Introduction to SQL Programming, that Pelican database book. The workbook and printed copy of the companion textbook may be purchased from lulu.com. You may download the textbook for free in ebook format from beckplanet.com/books. Important note on SQL Server and MySQL. The material presented supports both the SQL Server and MySQL environments. Where differences in SQL dialect and environment arise, solutions for both environments will be demonstrated. Where the SQL code is common across environments, only one environment is used for demonstration, as the code runs identically in the other environment. Chapter 6, Parallel Exercises. Solution Walkthrough with Commentary. Preparation. Make certain you have connected to your DBMS, SQL Server or MySQL, using your query client, e.g. SSMS or MySQL Workbench. If the Candy database already exists, it's a good idea to start by dropping and recreating it so that everything is in the expected startup state. Run the Candy database creation script appropriate to your DBMS, SQL Server or MySQL. Review the script execution results to ensure that the database and its data were successfully created. Parallel Exercise 1. Using the Candy database, create a view named Below Average Price. It consists of the product number, description, manufacturer number, quantity on hand, warehouse location, and price of every candy whose price is below the current average candy price. Parallel Exercise 1 asks us to create the view below average price, and the key to addressing the creation of any view is to generally start with a select. So we can craft the select that gives us the results that we want to define for the view and test that. And that's working nicely with all the fields selected. And of course, since in this case all the fields are being selected, we could alternatively simply do a select star would be logically equivalent. And so that works just as well. One of the differences here is that if you select specifically the fields that you want to enumerate, then if there are any changes to the underlying base table, they will not propagate in the view, as opposed to if you have done select star and then fields are added to the base table, they would also be incorporated into the view. So you need to think about your intent there. There's also a rather advanced idea about efficiency and covering indexes. Generally speaking, we try to avoid a select star if it is not needed. If there is an index that happens to include all of the fields that are needed, that's called a covering index. We'll leave that for an advanced SQL lesson. For now, I'm going to go back to enumerating exactly the fields that we want to include in the view. Test that again, and that's working happily. And so now all we need to do to transform this into a SQL statement to create the view is to prepend the create view statement there and rerun it. And the results show us that the view was correctly created. Let's go ahead and test that empirically. We can do that by changing this to a select star from below average price. And test that. And there are the identical results from the view we have created. Parallel Exercise 2. Using the Candy database, write and execute the command to retrieve the product number and description of each candy in the below average cost view produced by the manufacturer named Hans Riegel. Use the manufacturer's name, not the manufacturer number, in your solution. Parallel exercise 2 demonstrates that we can use a view as a substitute for a table, and we can use that in a join and then apply a filter just as we have done many times before without using a view, just using the base tables. So we're going to select the product num and description, and that's going to come from the below average price view, which we're going to alias as B, and manufacturer table, which we're going to alias as M, and then we're going to join those two where the manufacturer num between B and M are equivalent. And we run that and we see that we get results. And now we just need to apply our filter, and we want to filter here where the manufacturer name is Hans Riegel. So we can just add that in to our where clause and test it, and that runs beautifully.
Parallel exercise 3. Using the Candy database, create a view named Client Orders. It consists of the client number, client name, order number, order date, product number, and quantity ordered for all orders currently on file.
Parallel exercise 3 continues our exploration of views, and we're going to create another view. And having seen previously that you can use a view in place of a table to do a join, you may be wondering, well, can I implement a join right in the definition of the view? Can I join two or more tables? And the answer is yes, absolutely you can, and let's see that here. So using what we learned previously, we'll start to craft our view by beginning with the select statement. And here we have a select statement involving the client, orders, and order prod table. For economy, we'll alias client, orders, and order prod respectively as C, O, and OP. And then we know that if we have three tables that we are joining, we expect to see at least two equal signs in the join expression. We're using an implicit join expression in the where clause here, and we see those two. So that makes us confident that we have not created a blown join or a Cartesian product accidentally. And let's test our result. And on inspection, this is the desired result. So now we're ready to transform this to create our view, and all we need to do is add the create view statement before the select statement and execute that, and we see that that ran correctly. And again, we can test that empirically by just creating a select star on the newly created view and sanity check that that gives us the same result as the select on the base tables that defines the view, and it does, so we are done.
Parallel exercise 4. Using the Candy database, write and execute the command to retrieve the client name, product number, and order number for all orders in the Client Orders view for candies with an order quantity that exceeds 740.
Exercise 4 has us executing a simple select query against the client orders view that we just created. Let's take a look at that. And this seems almost too simple, like back to our elementary SQL, just running a simple select against a table. And that is exactly the point, that having created a view which encapsulates some of the complexity of whatever the view does in manipulating the data from the base tables, we can then go about our business of writing queries which are actually fairly sophisticated because a lot of the complexity is hidden from us or encapsulated in the view that we've already created. Let's run that and see if that works. And it does. And wow, that really is a lot more simple than having to write the equivalent query without the view that would have to manipulate the base tables involved in the view and any filter expressions and things that the view is doing for us. And that is exactly the point.
Parallel exercise 5. The Candy Corporation negotiates their cost, the price they pay to the manufacturer, based on overall volume levels. The more candy product they sell, the lower their average wholesale cost. Using the Candy database, create a view named Estimated Gross Profit, which estimates the firm's historical gross profit by product number, assuming they achieve sales volumes that brings their actual costs down to 39.5% of the standard price they charge their clients. The view consists of the product number and a calculated field indicating the estimated gross profit earned by the total sales of each item to date. Gross profit per product is determined by the quantity of that product that has been ordered, times the difference between the item's price and assumed wholesale cost. Remember, the assumption here is that a wholesale cost level of 39.5% of the price to the client will be reached. Hint: you will need to group by product number in order to correctly aggregate the sum of the gross profit earned by each candy. Use estimated gross profit as the name for the calculated field.
Parallel exercise 6.5 requires us to create a view named Estimated Gross Profit, and the basis for this view is going to be a select query on multiple tables, and it's going to involve both a calculated field, aliased to Estimated Gross Profit, and a group by clause. So as usual, let's craft the select statement. And here we have the select statement based on the order prod table aliased as OP, the product table aliased as P, and our expression here, an aggregate expression, which is why we're going to include a group by, is a sum of the quantity of the price minus 0.395 times the price, and that times the quantity ordered, and that's going to give us our estimated gross profit for this calculation. And then we will group those by the product number on the P table, that is to say the products table. So let's check and make sure that our select query is working as intended. And that looks nice. And as usual, once that's out of the way, all we need to do is prepend the create statement and run that to create the view. And we see that the result indicates that the view is created, but we can also, as usual, check empirically by selecting star on the view to confirm that the view was correctly created.
Parallel exercise 6. Use the Candy database. Write and execute the command to retrieve the product number for only the candy or candies that generated the highest estimated gross profit. Hint: this may be done with a subquery.
Parallel exercise 6 really brings home an understanding of why having a view can simplify your design and your crafting of additional queries. Because in this case, we're going to create a query involving the view that we've just created, estimated gross profit, but we're also going to have a subquery on this. And the subquery is going to give us the maximum value of the estimated gross profit from that view. So let's start with that, the innermost query. A lot of times if you have queries on queries or subqueries, starting on the innermost query and then working your way out can help simplify construction. So here is the innermost query that's going to determine the max value that we want to work with for filtering and comparison. Let's test that and see if that's working correctly. Okay, good. So now we have an expression that gives us the value that we need to equal. And so let's wrap that up in parentheses and make that into a subquery. And the query expression for the outer expression is this. We're going to select the product num from the view where the estimated gross profit is equal to that maximum value. Now, if you're wondering, well, couldn't I just look this up and hard code, plug in 779.966? It's like, well, yes, you could at that point of time for the values that are currently in the database. But remember that maximum value can change over time as the data is always changing. And so we really want to use a subquery that gives us a dynamic lookup of what currently at any given point in time that we rerun this query is the maximum value of the estimated gross profit. And so that's why we go through this kind of convolution. All right, so let's test that. And there we go. We get the answer that in this case, only a single record is equal to the maximum value, and that is the record for product number 112.
Parallel exercise 7, Pick List project. Using the Candy database, create a view named Pick List, which is to be used by the fulfillment department to help warehouse workers fill open orders. In filling an order, a warehouse worker fills one order at a time, pulling the products for that order and placing them into a bin for packing. The bin, marked with the order number, is then placed in the packing area next to the shipping dock, ready for packing, labeling, and shipping. The view is to list the client number, order date, order number, quantity ordered, product number, and description of each candy ordered. Assume that we are filling orders on May 9th, 2022, and generate the pick list for all orders made on or after April 15th, 2022.
Parallel exercise 7 involves a multi-table join and one filter criteria, and it's pretty straightforward. So let's start again with the select query for that. So here we are going to join the orders table, order prod, and product table, aliased respectively as O, OP, and P. And we are going to make sure that, again, if we've got three tables, we should see two linkages in the join clause. In this case, again, we're using the where, so it's an implicit join. I see two equal signs for three tables, so always one less equal sign than there are tables, and that gives me confidence that we have not created a Cartesian product or a blown join. And our filter criteria is going to be order date greater than or equal to April 15th of 2022. So there we have our select query. Let's test it. And that passes visual inspection and sanity check. Looks like it meets all the criteria we're intending. And so let's go ahead and add the create statement to turn that into a view. And execute it. And looks like that ran correctly. And as usual, we can do a select star on the view we've created to empirically inspect that things are as expected. There they are, and so that all appears to be working nicely.
Parallel exercise 8, Pack Order project. Using the Candy database, create a view named Pack List, which is to be used by the fulfillment department to help warehouse workers ship open orders. In packing an order, a warehouse worker pulls a bin from the packing area and prints a shipping label for the order. The worker then packs the order into a box, seals it, and affixes a shipping label. The shipment is then placed onto the shipping dock for dispatch. The view is to list the client name, street address, city, state, postal code, the date of the order, and the order ID. Assume that we are packing orders on May 9th, 2022, and generate the pack list for all orders made on or after April 15th, 2022.
Parallel exercise 8 is similar to and the complement of exercise 7. In exercise 7, we generated a pick list for our warehouse operation, and here we're going to, having picked the order, generate a packing list at the pack list project. So let's start again with our select query that is going to generate the view. We see our two tables, client and orders, appropriately aliased, and our filter criteria, order date being greater than or equal to April 15th of 2022, and we're ready to test that. And that sanity checks, looks correct. And so we can now transform that from a select query by adding the create statement to create the view, execute that, and that appears to have been created successfully and run successfully. So now let's visually inspect the view itself, and that all looks correct.
Parallel exercise 9. Using the candy database, create a query to display the product number and description for every candy whose price is less than the average candy price and which was manufactured by Hans Riegel. Once you have solved this exercise, you should notice that this one query is equivalent to parallel exercises 1 and 2 combined. You should also reflect on the ease of using the view as in parallel exercise 2 compared with the additional effort and complexity of encapsulating all the required logic into a single query. The idea here is to gain a first-hand appreciation of the convenience and utility of views.
The point of parallel exercise 9 is to compel you to create the equivalent of what you achieved with parallel exercises 1 and 2 using a view, but to do that without a view so that you gain a greater appreciation of how much a view can truly simplify the creation of your code. And so what we'll need to do in exercise 9 is use a subquery because we need to filter things on being equal to the average price. So what we've learned before is that it is easiest to start with the inmost query if we're crafting a subquery. And so here's the expression that will generate the average price from the products table. Let's check that. And that looks correct. And now we're going to take that query, since it's going to be the subquery or the inner query, we're going to package that up and add the rest of the query code. And so we are selecting the product num and description fields from the tables product and manufacturer, which we have appropriately aliased. And two tables, we should have one linkage in the join clause, and we do. And then our additional filter here is that the manufacturer name must equal Hans Riegel, and the price is going to be greater than the expression we originally formulated as the inner query, the average price. So all the price of everything we're looking at is going to be, less than average. And let's run that. And there we are. So our select query is working properly. And if you go back and look at what you achieved in exercises 1 and 2, you can see that that was a lot simpler conceptually to construct when you already had part of the problem solved by using the view. And that is exactly the point.
Parallel exercise 10. Using the Candy database, create a query which displays the client name, product number, and order number for all orders with an order quantity that exceeds 740 for a single line item. Once you have solved this exercise, you should notice that this one query is equivalent to parallel exercises 3 and 4 combined. You should once again reflect on the ease of using the view as in parallel exercise 4, compared with the additional effort and complexity of encapsulating all the required logic into a single query. Again, the idea here is to develop a first-hand appreciation of the convenience and utility of views.
Parallel exercise 10 is another take on emphasizing why a view helps to make things simpler when you're crafting your code, and that could be simpler for you, the developer, or it could also be simpler for your end users if you're providing end user query tools. Creating views can greatly simplify the complexities of the data model that you're working with, so that non-technical users can make good and effective use of the enterprise data without having to have a developer working for them. So food for thought. Let's take a look at exercise 10 by looking first back at exercise 3 and 4. So this was our solution to exercise 4. And you see that basically we've got 3 lines that do all the work because we are doing with the view, which had solved part of the problem for us. Now let's compare that with what we need to do in exercise 10 to achieve the exact same thing, but without the view. And so here we have to essentially encapsulate the logic that was creating the view for us in and add the filter that we added in exercise 4. And so there's a lot more heavy lifting to do. This is a fairly simple case, but you can imagine as your queries get more and more complicated, how much more complicated things might become without the view. So even if you create views temporarily to help in your development process, they're still very, very useful. So let's give this a try. And very good. So our join worked successfully and our filter worked successfully. And here are our results. And the problem is solved, but with a little bit more effort perhaps than what we did in exercise 4 to achieve the same thing.
Thank you for watching. Please visit beckplanet.com/books for additional free student and instructor learning resources, a free ebook copy of Beck's Introduction to SQL Programming, that Pelican database book, and to learn more about print editions of the textbook and workbook.